Hey, welcome back, my friends. So today we're going to go over muscular skeletal. One moment. We're going to be going over muscular structure. Anything you hear in the background is just my family. Um, this is what we'll be looking at, mainly when it comes to what we're talking about. Shouldn't be too long a video. I'll try to keep it pretty short. Um, I'm also going to be reading from this and using this to help visualize, but mainly I'll probably be here pointing at words here with my mouse and pointing to what they are trying to tell you about here on the diagram, etc. So the reason I did this video is because somebody asked for help with the upcoming skeletal muscle unit test. The upcoming isn't going to need anything from BioDigital, great company by the way. So I didn't include them in this video. I probably will though the next one when it comes to the lab practical. All right, on with the video. So everything that my class is going to need for this test is on here. I'm sorry if you're taking class and it doesn't help you for yours. By the way, I think Wardlaw, our teacher, used BioDigital for this. Good job. I'm sorry if it doesn't help you, but not much I can do about it. But here's to hoping you learn something. That's the point. So, muscles. I feel really remiss. I'm sorry, guys. I just feel really remiss that I can't receive your questions as I'm recording. But the next best bet is to see them in comments below. Please make sure to comment because otherwise I feel like I'm just talking at my camera. I feel so lonely. Anyway, also, if you would share this video, you could help your friends with anything they might have, tests, general questions and knowledge, or just share my channel. I do more than just tutorial stuff. I also do gaming, entertainment, and anything else you guys ask me to do that I'm okay with doing. Please make sure to share. Subscribe if you want to see this more often or anything else I do. Please. I get lonely. Anyway, so muscles. Sorry, people who actually care about what this particular video is about. So yeah, muscles. So their purpose is to move you or parts of you in any way, shape, or form. That's how I'm doing this forever. Okay, fine, not forever, but still. So yeah, movement or motion, such as so skeletal moves your skeleton, obviously. It's attached to bone and it does stuff with your bone and your bone does stuff with it, etc. Cardiac is attached to your it's attached to itself, but it's your heart. It's your heart and it goes keeping your blood going everywhere. Just everywhere. Smooth muscle is different from these two because it's unstriated, which means when you look at it, it's not it doesn't have all these lines like this. It's just kind of flat. Therefore, smooth muscle. And smooth muscle is, well, it's usually non-voluntary. That's the main way it's been set apart in our course. It's just usually you don't really care about it. So, or if you do care about it, you know what? You probably do care about it because it's what moves the food through your digestive system. It's what moves your food through your digestive system and keeps the stuff that would be embarrassing to have outside of your digestive system in your digestive system, like urine and feces. It keeps them in there. And then it also keeps you from moving when you don't want to move. Like when you want to sit up straight and stay sitting up straight, it keeps you there. It also, well, like this, it keeps your joints together. Otherwise, they just kind of, your limbs would just kind of fall off. And something that almost no other muscle does, they keep you warm, which is important because if you're not warm, you'll freeze. Humans need to maintain a temperature relative 98.6 degrees, and if it's too high or too low, you die. And your muscles keep it from being too low, so that's important. And even if it's not low enough that you're dying, but high enough that you're going to, if it's not it's not so low that you're dying, but if it's not low enough that you're dying, but still problematic, then you get things like hypothermia and sickness and wishing you were dead. So yeah, muscle is special in these ways. It's the only kind of it's the only kind of cell in your body. Admittedly, you have a lot of it, but it's the only kind that it's excitable. It reacts in a particular way. All of your cells react in many ways, but your muscle cells change shape when made to react, and that's their the next ability, their ability to change shape, and they can also be stretched or extended without being broken, and their main and most important one is that they can return to their original shape without being damaged. Therefore, I can do this for a while, and it probably looks really weird on your thing in the corner, but such as it is. There are plenty of different types of muscles, like we've already discussed. I'm sorry if this thing is being weird. It's just, it's what I was provided for class with Wardlaw. It's under Unit 3 Muscular System under the name Whole Bunch of Muscle Knowledge. You can tell he named it himself. He told us so. So all muscle tissue is composed of muscle fibers, like this. But there's three main types: skeletal, attached to your skeleton; cardiac, your heart; and smooth muscle, which is mostly in your digestive system. Naming skeletal muscles there are plenty of factors that go into it, mainly location, shape. Next page, please. Thank you. Size, how big it is, direction it's going, and where it attaches, because skeletal muscles especially have attachment points that can make them unique, and the number of things, and then what they do, like the main things they do. So location, some location terms are temporalis, like in your next to your ear. Abdominis, like in your abdomen. Your femoris, like on your leg. Tibialis, like on your shin. And some shape examples are your deltoid, your trapezius, rhomboidus, anything that has a shape like you can see here. These are some size examples and their meaning right here. I really hope you guys can see that. The direction. So most of the direction things are talking about towards your midline, the very center line of your body. Rectus would be like just straight up and down. Transversus would be side to side, and oblique would be diagonal in any direction. Your bicep, or my bicep rather, is a great example because it only has two insertion points right here, insertion/origin points right here and right here. This is the insertion point because it's the most mobile point, therefore it's the insertion, and this is the origin because it's the least mobile point of attachment. So, bleh! Anyway, and then the number of origins, like my bicep, this is just my brachial bicep, meaning it's on my arm. Your femoral bicep is on your leg, and it's called a bicep because it has only two attachments, biceps. Seps, attachment, and bi, two. So two attachments. Your triceps on the backside of your arm have three attachments. Therefore, tricep. And action. Oh my goodness. Where did the time go? Okay. So yeah, examples. I'm sorry. I'm sorry. I'll probably edit this. So there are some things that my class will be needing to know here, and maybe you'll want to know it too. So in any muscular action, there's a group of muscles with roles in that action. So when I do this, there are lots of muscles involved in this motion. Mostly this one. This one is called the agonist. It's what mainly moves you. This is your antagonist. It's what moves you back, because each of your muscles can only contract in one direction, and they all have an oppositional muscle doing the opposite. But this muscle isn't the only muscle helping in this movement. There's also this muscle that there's also this actually in this movement, yeah, that's it. No, there's also this muscle that's making it a little bit easier to keep it, and then there's a fixator right here. This is my deltoid. It's keeping my arm in place so that I can show you guys, and it keeps up. And so basically it helps a lot. And the biggest chunk, I'm glad I got to this before I got halfway through my time limit. One moment. All right, thank you for your patience. Probably went by real fast for you. So I'm going to read this and point out what it's talking about and explain it. Muscles and groups of muscles are separated from one another by a sheet of dense connective tissue called fascia. So fascia is this. Around any particular muscle, there's this wrap. It's called fascia, and it's what keeps all of your muscles together as the one muscle. Skeletal muscle Skeletal muscle is surrounded by dense fibrous connective tissue called epimysium. So epimysium right here. So you see this purplish thing? There's a clear separation right here. It's invisible, not clear. It's just an invisible separation right here. No, it's not invisible. It's this white line all the way around it. That's another thing like this, but a little bit denser. This is called an epimysium. This is denser than the epimysium, and the epimysium is super thin. Next is the paramysium. So around all of these, which are called fascicles, so see how this has been extended? So each of these little bunches is one of these, and they're called fascicles, and they're surrounded by another layer of wrapping called paramysium. And then each of these has little cubby compartments, and amongst those, these are each wrapped by another thin layer of connective tissue called endomysium. So it's in your muscle, and then this is around your muscle, and this is on top of your muscle, for anyone who cares about Latin roots. Fascia, I don't know how to remember it. You know what? That's a good thing to comment about. You should do that. So there's the paramysium, then the endomysium, and then within each of these little groups, which are actually the single muscle cells. So each of these is a muscle cell, and they can get really thick, but you only have so many muscle cells in any given muscle, but they can get real fat real fast. And that's a good thing. You want fat muscles because that means they're strong. So each of these muscle cells, you'll see they're also composed of lots and lots and lots of tiny little groups. And those are called sarcomeres. So sarcomeres, the word comes from sarco, which means flesh, or in this case, muscle. So we're going to say muscle. So it means muscle ear. And man, I don't know. Oh, wait. Yes, I do. Mere. From the Latin root mere, which is measure. So this is one sarcomere, which looks about from here to here. Actually, you know what? I'm going to need to show you a picture of a sarcomere because that's on the test too. But don't worry, I'll be relatively fast. Sarcomere. Images. I really hope you guys can see this. Oh, yeah, there I am. My little thing with the my face in it is on the screen now. So this is a flattened sarcomere. You see how in here it's all round and bunchy? Right here? This is a sarcomere. Or at least this is a myofibril. A bunch of these myofibrils make up a sarcomere, and they're only about this long. From here to here is one sarcomere. And then in these sarcomeres are bunches of all these myofibril. And this is what gives muscles their ability to change shape and their elasticity and their awesomeness and what makes them so useful. So one time I'm going to go over review of layers. So there's the fascia around the epimysium, which is around groups of fascicles, and each fascicle is surrounded by a paramecium, and each fascicle is a bunch of muscle cells surrounded by an endomecium, and each of these within each of these muscle cells is a bunch of each length of these muscle cells is called a sarcomere. No, wait, that's on the myofibril. So each length of sorry. So each muscle cell, this is one muscle cell. It's changing shape, this whole thing. Yes, all the way down there. It's one muscle cell, but you have so many of these. So, yeah. But each muscle cell separation is called a sarcomere in length. And this is a sarcomere by itself. You see how it's round? So this is a cutout version. The blue ones here are thick filaments, and the red ones here are thin filaments, and they're myofibril. That's the very smallest before we get into individual proteins. These are molecular size, guys. But admittedly, they're huge molecules, like gigantes, like thousands of atoms. No, not even millions of atoms. But they're still proteins. So, this is a sarcomere. You see these little branches off of this thick filament, which is obviously thicker than these filaments. So the thick filament is called myosin. And these little branches off of the myosin, this is a flattened sarcomere, by the way. It's been flattened so that we can see it. These little branches are called myosin heads, and they have the ability to latch onto this other filament called actin, because it's made of actin. So this, however, this actin is surrounded by, it's not in this diagram, but it's surrounded by this other filament called tropomyosin, and all its job is to do is to keep these heads from attaching. Otherwise, they'd be attaching all the time. So it's there so that it's in the relaxed state, so that we're not and stays there. Because otherwise, our heart wouldn't beat; it'd just beat once and then stop, and we'd be dead. And so that tropomyosin is important so that we can, stay alive. Oh my gosh, I only have 7 minutes left. I'm going to hurry up. That tropomyosin keeps us from... Okay, so... Sorry. Where's I? Right. So tropomyosin keeps the heads from attaching. And so when tropomyosin is removed by a rush of calcium released from this bag called this sarcoplasmic reticulum, it's yellow here. When that bag releases calcium, the tropomyosin moves away and allows the myosin heads to attach to the actin, and then they can inch their way forward. And what we have is movement. I'm going to make another video explaining more about muscles and about the structure of the cell. But I think I'm going to wrap up this video with sarcomeres. Don't forget to comment, share, and subscribe, etc. Anyway, so when the key in points, so on this actin, under the rope of the tropomyosin, are little proteins called troponin, where the ends of these myosin heads detach and attach to the next one and pull up, changing the shape. and then when the tropomyosin blocks these heads from touching the troponin, they get knocked off, and this all slides apart. But when they're contracting, this and this get closer together, which is contraction. When they let go, they get further apart because they're just relaxing. All right, so this, you see how it ends right? The actin ends right here and kind of makes this honeycomb. It's called a Z disc here. And there's a Z disc on the end of each sarcomere. An A band. So you remember how when I said when you look at, there's another one here. You know how when you look at flattened muscle cell, it looks like this? So those stripes have names, and those names are here. So it's mostly around the myosin, this giant thick filament. The A band is the entire length of the myosin. The I band, which doesn't have myosin and therefore is much lighter because it doesn't have the thick filaments, is between the end of this myosin filament and the one before it. The M line is down the middle of this A band, or all of these myosin filaments. That's down the middle is the M line. So Z disc is the actin line. I band is from the end of this to this myosin filament to the one before it, and the A band is the length of these going all the way down. So, and then there's another one you need to know that's not here. It's the H zone. It's the distance between this actin filament and this actin filament, which shrinks when the sarcomere contracts. All right, I think that's about all I can cover in this video. Thanks for watching, and never stop learning. Thanks. Bye. Never stop learning. I'm going to end now.